Up next, we will have our second speaker, Mike Durham of the Hybrid Air Vehicles UK. Mike is the Chief Technical Officer of Hybrid Air Vehicles and a graduate of Loughborough University with a degree in aeronautical engineering. Mike has over 30 years experience developing lighter-than-air technologies, and he became the Chief Engineer of HAV at its inception, as well as the Technical Director in 2010. He leads the technical development of all HAV's products, and Mike will be talking to us today about HAV's progress on the Airlander family of hybrid aircraft, as well as the production and type certification program for Airlander 10. Mike, the floor is yours.
Thank you very much, Ross. Let's try and do the technically bit and share the screen properly. Good. Okay. Well, we'll call that a vague success. This is the trouble with letting a CTO anywhere near technology. It's never going to win first time. So good morning, good afternoon, everybody. My first job is to apologise. Originally, Tom Grundy, our CEO at Hybrid Air Vehicles, was going to be talking to you. He's not able to be here due to other commitments. He's out chasing finance, amongst other things. So that means you've got to listen to an engineer talking about the sort of commercial and economic cases for Airlander and, our path to market. So apologies again in advance, as I'm likely to diverge into technical stuff at the first opportunity. So let's see how we go, So we were incorporated back in 2007, but many of us have been doing it for a long time prior to that. We were born out of airship industries back in the 70s. But really, HAV came into being solely focused on developing hybrid aircraft. We were lucky enough to win the LENVI contract with Northrop Grumman back in 2010. It gave us a huge opportunity to build a full-size prototype, albeit for quite a specific operational need. And we got that one built in less than 2 years, flew it out of Lakehurst in 2012. And then with sequestration and so forth, we had the opportunity to buy that aircraft from the US military. We brought it home to the UK in 2014. And we did a bit of tweaking and modification to it, shall we say, 400 or 500 mods. And it evolved into effectively the prototype for the Airlander 10 product. And then we took it flight testing for a year or so. So what is a hybrid aircraft? We sort of see it as merging the best aspects of lighter than air technology and conventional airplane technology. We're trying to produce an efficient and commercially viable transport device, a truck of the air, if you like. But just to be clear right up front, we don't see hybrid aircraft as replacements for airships or airplanes or helicopters. There are right roles for all these aircraft types. And we see each has got its role to play. And that's how sort of going in position. Equally, we also see some of the competition for Airlander coming from surface transportation. Certainly as you go to the larger variants of our vehicle, we see us competing with ships and trucks on some routes. But again, this isn't a one-size-fits-all sort of solution. So HAV's goal is to produce an aircraft that, via its LTA heritage, produces a low-cost means of transporting stuff. Okay, at modest speed, but the upside, significantly reduced CO2, if not zero CO2, when compared to existing aeroplanes and other transport means. So over the last 3 years or so, we've been putting a lot of effort into optimizing not just the technical product, but the return on investment for operators. We've been working with many potential customers, trying to make sure we get the mix of vehicle technology, which obviously is the center of everything as far as I'm concerned, but mixing that right with operational cost and making the right choices about size and all of this sort of stuff. So we've been very much engaged with a large customer base talking about what's the right product to use. It's created a set of key user requirements, as we call them within HAV, and fundamentally that's what we've then taken our learning from the prototype aircraft and melded that with those user requirements. And we end up with the Airlander 10 production vehicle. I think one of our biggest challenges that we've seen with LTA, and I've experienced quite a bit of this over the many years, is making sure we get the ground operational aspect of LTA right. There's no doubt, once you're up in the sky, it's pretty straightforward. But the ground interface piece, that's where the challenges can be. We're trying to get ourselves away from having to have a mast or a large amount of ground infrastructure at every location we visit. And this is part of why we've gone the hybrid route. It gives us a wide spaced, stable landing system. It means that we can put it down on a multitude of surfaces and so on. And, you know, the helium is a great thing in every respect bar one, if only you could turn it off when you wanted to. That's the biggest problem we face as an industry. So, and again, we've developed Airlander to try and help us with this, making us a bit more like an aircraft, so that we're only sort of 80% reliant on the helium piece. It gives us a slightly wider operating envelope to be able to work to, without having to get into gas compression or you know, ballasting of other sorts. It doesn't solve the whole problem. Airlander is not a complete solution to it. We really do need a backhaul on, you know, freight journeys and so forth. But in the main, from our conversations with potential customers, there nearly always is a backhaul of some form, even if it's only 60 or 70% of the weight fraction. It still helps us. So that's a key thing for us. The pictures on the screen just show the sort of various steps that we've gone through in terms of scale model stuff, and then getting Lemvy flying in the top right picture, and then converting it into Airlander back in the UK. But the roles we're currently focused in on, and this is purely about Airlander 10 today. I'll talk a little bit to our expansion plans in due course, but really, for Airlander 10, it's a bit on the small side for a full-up freighter. We've talked to customers, and there are definitely niche markets for 10 to 12 tons of freight over, you know, 1,000 miles. But really, you want economy of scale, and that's where we drive to with our bigger products for the freight side of things. What we have picked up from customers, they are so keen to be able to operate from water. There's a lot of enthusiasm for getting away from having to have, well, there's a lot of enthusiasm getting away from airports to start with. But if we can get away from finding greenfield sites or, you know, landing on rocks and stuff, water operation is definitely a flavour of the month, shall we say, at the moment from the customer base we've seen. And it's that enables us on some of the configurations for Airlander 10. So passenger mobility, we've been looking at sort of the 100-seat area of city to city passenger movement. And there's no doubt there's some real enthusiasm out there to be able, not necessarily to get from city centre to city centre any quicker, but to do it different. And one of the opportunities for us is, you know, many city centres or close to near to, they have large areas of water. There is an opportunity to change the sort of the number of segments of travel you have, not have to go out of town to an airport and then sort of back into town from the airport at the other end. So what you find is that actually, although we're significantly slower than a typical regional aircraft, or even a 737, whatever, although we're slower, if we can operate from closer into the city, the overall time of journey from city centre to city centre isn't a lot worse via a hybrid aircraft or airship type solution. And I think the general public is beginning to wake up to the fact that overall journey time, yeah, that's okay, that's good. We'll be in the ballpark there. But if we can do it in both a greener manner, i.e. get rid of all that nasty carbon being generated, and also do it perhaps in a more comfortable manner, doing it in an environment that is not being crammed into a tube with your next door neighbour's elbow in your ribs sort of thing. We really feel that there's an opportunity in mobility, passenger operations that we can grow into. As I said, the freight side of things, it's a little bit more restricted with Airlander 10, but we're still seeing there are some particular routes that might prove sensible for us. Surveillance, another marketplace. There's no doubt the military still remain interested in it. You know, surveillance doesn't go away, and doing it in a cost-effective manner. We've been working with the NPS, the Marine Corps School over in California, for the last 6 months on a CRADA program, and it's really interesting to hear from the military about the fact they are being pushed towards greener solutions for their flying and their transport needs and so on. So I think there are still opportunities on that side of the fence. And the final piece, which is sort of where some of our early adopters are going to be sitting, is sort of the expeditionary tourism. But the idea of going somewhere without leaving a trail of carbon behind you, and you know, yes, this is the more upmarket end of things. We're looking, you know, an Airlander 10, we're probably looking at 20 passengers in sort of 10 double ensuite cabins and all the rest of it. That's sort of the picture on bottom right. But experiential tourism is a part of the potential mix. So what we've ended up with effectively is an aircraft that's much more flexible than the Lenvie aircraft. We're designing for a much wider marketplace. So where that takes us to is we've got to develop some technology, and really there's a couple of places we've got to go that will make us more efficient. We want to be early adopters of scalable zero carbon technology. There's huge opportunity here for us to help the aviation industry meet its sort of 2050 carbon targets and so forth. We have an opportunity with Airlander 10, although our first few Airlander 10s will almost certainly be kerosene powered, albeit almost certainly by then SAF. We're already on a path with hybrid electric power towards, you know, by the time we're 8 or 10 Airlander 10s in, we'll be hybrid electric, so combustion engines and electric engines and fuel cells. And by about 2028, hopefully, fully electric Airlander 10s. And the pathway then moves on into the other aspect of how we make these vehicles more efficient, which is let's take that fundamental of light and air. Bigger is better. Volumetric efficiency. And, you know, the bigger we go, in actual fact, the cheaper these things per ton kilometre of freight and so forth, the cheaper they are to operate. Now, there are practical limits in there, obviously, and if you're trying to serve a remote community that only wants, you know, 10 tons of stuff delivered once a month, it's probably not, you know, it's not going to be cost effective to rock up there once a month with 100 tons of freight on board. So there will be horses for courses in this. But, you know, our next steps beyond Airlander 10 are towards Airlander 50 tons of freight, that sort of order, 50 to 60, depending on the range. But we're already having conversations up in the 200 and 300 tons of freight range in due course. But at that sort of scale, what you're then moving into is you're sort of more competing with the shipping industry. You're starting to look at bulk freight in intercontinental ranges and so on. So there's a huge potential out there for our industry. The challenge is making sure that LTA is perceived to be a safe set of hands again. And there are really there's a couple of problems we have to get over. And I've spent most of my LTA life dealing with the first one, which is the preconceptions based on the distant past. I'd prefer to call them misconceptions, but there is no doubt, you know, if I was in the shipping industry, I'd be deeply peeved if the first thing that everybody talked about was the Titanic. In our industry, there's another product out there that everybody leaps in on at the start and annoys the hell out of me even now. The other challenge for us all, I think, is we're bringing a disruptive technology to market in many respects. You know, the world has got comfortable with aeroplanes and helicopters. You know, the world of lighter than air, it is a disruptive technology. It means it can be challenging to get the public to accept it. It can be challenging to find finance and so on. So those are the big challenges currently going on. Hopefully over the coming month or two, we'll have some more news out of HAV that will show that we've got some of those not necessarily licked, but well under control. So the one thing that we've really found that's important over these last 3 or 4 years is collaboration. And the LTA world, if ever, it really needs to find ways to collaborate and make sure that we as an industry present a viable and a strong, whether it be safety or whether it be technology or whether it be operational, the operational side of things. It's important that we demonstrate to the rest of the world that we know what we're doing. So over the last few years, HAV's been working with both the LTA community, and on the next slide, I'll talk about some of the non-LTA community that we've been working with, both on design projects, operational and regulatory type projects and so forth. HAV and Flying Whales have spent significant time and effort on the development of SC gas with EASA, despite the fact that obviously the UK cut Europe off a couple of years ago and let them drift off the other side of the channel completely. But the SC gas regulations, they're very important to us, despite us not being quite so closely tied to EASA anymore. And between Flying Whales and ourselves, and then with review and oversight from EASA, we put together a sort of high-level set of safety codes. It's important that HAV, despite casting Europe adrift, it's so important for HAV still to be connected to the rest of the world in terms of regulation. It's no good for us just to certify a product under CAA in the UK. We need to certify products worldwide. So, our certification plan, although it will be headed up with the CAA, we'll be doing concurrent certification with the EASA and FAA as we move forward. We have had conversations with Transport Canada as well, and I think they'll play an integral part in our cert program as we move the product towards type certificate. But anyway, so a lot of work went on between ourselves and Flying Whales on that, great collaboration. Equally, while that was going on, a different bunch of us within Flying Whales, Zeppelin, WDL and ourselves have been working on development and refinement of some of the operating rules. There's no doubt that airship operating rules have lagged a little bit behind the rest of the world, but there's really starting to be a need now for us to understand and for us to know what the rules are going to be when we come to have to train pilots and maintainers and operators and so forth. And, what's the standard going to be for flight simulators? What are the crew flying hour limitations going to be? What pilot training are we going to do? What are the steps you go through to become an accredited airlander pilot, for instance? All of this is important. It has a significant impact both on the operating cost. We want to be cost effective, but also it has an impact on the design of the aircraft. So between the 4 businesses I just mentioned, we've been putting quite a lot of effort into trying to make sure, with the EASA in particular, that the training regulations and simulator regs and so forth are sensible and sort of align with the rest of the aviation industry. And the other example that I should bring up is Flying Whales and ourselves. We've been collaborating on a sort of very highbrow sort of article for the ICAO Sustainable Aviation event in the autumn. And that piece sort of talks to the benefits of lighter than air generally, rather than how brilliant our products are. But again, we need to raise LTA up in the public's mind and in industry and government. So moving from that, we have also been doing obviously some technical collaboration stuff, predominantly with Collins Aerospace, University of Nottingham, under some grant funding from ATI. So we've been building a high efficiency electric motor and controller system. We're due to go out onto a ground propeller test rig in 2 or 3 months' time and actually run the motor not just against a dyno but against a proper propeller, and get some views on some of the operating rules we might want for that. Do you go for constant speed propulsion, or do you have you use variable RPM? There are lots of different strategies to be worked out, and they have an effect on the motor, and varying the speed of the motor can be challenging and so on. So this is very useful for us. It's one of those sort of core pieces of technology in our journey towards electric propulsion. But I guess it's not all about aircraft technology. I can't really have said that. We have also got a number of commercial partners that we've been working with over the last few years. So we've got AECOM, who are effectively building infrastructure, civil specialists. We've got a big project ahead of us to develop our production facility. We want to do that in an appropriately sustainable manner. It's a great opportunity. We're building from scratch, in effect, and we want to do it right. We want to make sure that we're putting back into the local community, whether that be solar energy from on top of it, making sure rainwater runoff is captured properly, making sure we have efficient insulation systems, and all of the normal stuff that one should strive for these days in a green facility. So we're working with AECOM on baselining that. And then the other piece I touched on 5 minutes or so ago is about our partnership with 2Excel with regard to training of flight crews and technicians and the task ahead for that. We're looking at each of our airlanders. We're looking at them probably flying 3,000 to 4,000 hours a year. You're almost certainly going to have a couple of pilots on the flight deck. And for some reason, pilots seem to be so heavily protected, they're not allowed to do more than about 900 or 1,000 hours in charge a year each. So every airlander we build is going to require, 7 or 8 pilots to fly it over the course of that year. Our production plans are for many tens of aircraft. All of a sudden, we're looking at having to train hundreds of pilots. That's not an inconsequential thing, and hence our interest in the Airship Working Group with WDL and Zeppelin and Flying Whales and so on. We want to make sure we get the rules right with that, and 2Excel is one of our partners that is going to help us with that strategy for training pilots and getting crew qualified. The final group that we're tied into at the moment is the Advanced Manufacturing and Research Centre, spun out of Sheffield University a few years ago. They've got all sorts of amazing techie type stuff, both airborne, but more importantly, they're predominantly about how do you manufacture stuff? How do you do it efficiently? How do you maintain stuff efficiently? The days of having a paper job card and 3 pages torn out of the manual and sending a technician up onto the top of an airship, they're long gone. We need to be efficient with the way we maintain these aircraft. We need to be safe as well. We need to take any guesswork out of how you do a maintenance task. Our goal with Airlander is we don't sell people hangars, we sell Airlanders. They go outside, they'll be on a mast or they'll be flying, and they stay outside the whole year round. So our goal is that all maintenance can be done outdoors, and that's required us to sort of challenge ourselves on how best to really do maintenance. Finding somebody from the design office who's prepared to go up on an ascender system 100 foot in the air to look at a problem a technician can't describe, it doesn't work. You need to be looking at whether it's hollow glasses or 3D imagery and so forth. We want to make the whole of this a more efficient system. So the Airlander project has turned out to be much bigger than just building a few hybrid aircraft and gaining a type cert and doing a bit of technical stuff and having fun along the way. It's been very much about the end-to-end system, everything from training pilots to having facilities to supporting operators and making sure that the product will do what they want it to do. So we sort of see ourselves in a place where we've been a development business for many, many years. And now what we see ourselves as a production business. We've had the luxury, shall I call it? It's a horrible way of talking about COVID, which has been a terrible, terrible thing. But as an engineering team, we've managed to work through that. We've had the luxury of 2 extra years to make sure that the product we're bringing out answers the challenges that are out there. And it's going to be an exciting journey ahead. We're trying to deliver operational cost reductions to the transport industry. We're trying to support the initiatives like net zero and zero climate impact and so forth. There's a big challenge ahead, but we're sort of up with it. So just to wrap up, I'd like to say it'll be good to see a few more of you face to face at the conference later in the year. And I think at that conference, we'll probably focus a little bit more on the technology piece. What does an Airlander 10 actually do? How does it work for underserved places, the Canadian High North, for example, congested places? How might we work within containerized logistics? We'll talk a bit about our Airlander 50 and how that works as a container aircraft. But fundamentally, we sort of see the future of aerospace. It isn't a one-size-fits-all solution. And our goal is just to be able to deliver societal good whilst reducing the impact on the planet. And, that's what we're all about. So thank you for your time.
Thanks very much, Mike. That was a great presentation. We've got a few questions in the Q&A here. We got about 5 minutes or so, I think, till we need to move to the next speaker. So perhaps we could go through a couple of them if that would work for you.
Yeah.
It looks like perhaps there's the first question I see that's come in, or one of the first ones came in, was a question about the risk of wind when landing. I would imagine that you guys have some plans for that.
So takeoff and landing is something we've been spending a lot of time working on. From the prototype aircraft, obviously we had a few bumps along the way with that test aircraft. But at the end of the day, we learned so much about the behavior of that aircraft. It took us back into the wind tunnel, for instance, to modify the hull shape a little bit, to make it a little less pitch sensitive and so forth. We've learned huge amounts operating that prototype aircraft. And the takeoff and landing stuff, yes, we were lucky that before we lost that aircraft, we had matched our flight simulator. So our flight simulator has been like gold dust to us for the last 3 years, and we've done a lot of work on takeoff and landing technique and so forth, and making sure that we can operate in winds up to 30-35 knots for takeoff and landing. So it's part of recognizing that a product that can only take off and land in 10 knots of wind isn't going to be much use to the commercial industry. We've got to be better than that. We've got to be competitive with airplanes or helicopters.
Perfect. I guess there's another one here talking about just the Canadian conditions out of curiosity, the nature of the shape and the performance during the winter. Is there a risk of snow collecting on the top surface, or is there mitigation for that if it does?
So we obviously have to watch out for snow. We've done a lot of study work over the years on snow accretion. One of the challenges with snow tends to be what type of snow is it, and is it wet snow or is it dry snow and so forth. But we've obviously had to look at our aircraft from the standpoint of it may well be operating in regions where there is snow on a regular basis. And we've got some systems built into the aircraft and some maintenance systems that we use on the aircraft to make sure that we can mitigate that snow challenge.
Perfect. And I guess I think we got maybe time for one more question. Just the notion of you were talking about pilot training and things. What's the requirement likely to be for that, and about when might you start looking at doing the pilot training at the beginning of that?
So the regulatory side of pilot training is something that probably we're going to be arguing with the EASA and CAA and FAA and so forth. We'll probably be arguing with them for the next 2 years, knowing the way these things tend to grind along. But obviously for Airlander, we're looking at being flying in about 3 years on our flight test program. And we know we need in the order of 8 pilots to be able to execute that flight test program. So we've got to have a robust pilot training process of our own. So we've been working through the how many hours do you give them in a conventional airship, followed by how many hours on a simulator, followed by how many hours in an Airlander in the sort of P2 seat. So we're working that stuff. I'm very lucky to have Dave Burns as my chief test pilot still. He's got a huge sort of background knowledge in the LTA side of things, but also he does understand, civil aerospace pilot training as well. So a lot him along with others in the team here, we're just trying to make sure we've got a safe and practical process lined up, both to get ourselves flying for our test program, but then some of those pilots will almost certainly go off and become training pilots or instructors and so forth for our early customers. It's important to us that we support our early customers to make sure they don't commit sins.
Yeah, absolutely, for sure. Well, again, thank you so much for your time today, and I really very much appreciated the presentation. We're going to move on, I think, next